So, my name is Ryan Abbott. I am the systems architect for the Search and Discovery Train, which is just essentially an organizational unit within a NASA contract. We are responsible for the vast majority of searching and discovering NASA's Earth science data, specifically metadata. I am joined by a couple of my colleagues, Chris Goki. Why don't we do, you guys want to do intros real quick? You guys just come off your mics and do your introductions real quick.
Sure, I'll start. I'm Eric Ryder. I'm a developer for the Common Metadata Repository on the NASA EED program. And I'll be talking about SNS subscription implementation in the CMR here in a little bit.
Hello, I'm Chris Goki.
I'm so sorry to interrupt. It's just the sharing. The slides are not showing full screen. Brian, did you want to try again?
Yeah, I guess I'll share the window.
Chris, I apologize for interrupting you.
No, it's all good.
Is this any better?
No, we're seeing the next slide, and then we're seeing all of them down at the bottom.
Slide. I see. So
yeah, and you're in the presentation view, but we're seeing the author's view, not the actual presentation.
Yeah, it's because my monitors are... Okay, that should fix it. It puts a green outline around the other screen, which is fun. Slideshow, and there we go. And I do. No, you chose. We want this one. Okay, that should be better.
Perfect. Thank you.
Of course. All right, Chris, go ahead, buddy.
Yeah, I'll go back in camera. Yeah, so I'm Chris Goki. I am a software developer on the ED project. I work mainly with the search and discovery team. I be giving a talk today about keyword management system, kind of the state of where it's at and where the direction that we plan on going. That's all for me.
Awesome, thank you. So what we're presenting today, there's kind of an important message that I'm hoping to get out there today, and that is the amount in which we do or try to involve the feedback that comes to us from all over the place. And so we know that the tools that we create are crucial for many different people. And so we want to highlight the feedback that we've received, not specifically, but more the source of that feedback. And then we have 4 pieces of software or tools or projects that we have implemented this feedback in. And we wanted to kind of just give you a glimpse into what those new features look like and how that feedback came about. And so we are listening, and this is what we have done and accomplished over the last about 6 months, given that feedback. And that's what we want to highlight today. So I'm going to kick things off. I have 2 different projects I want to talk through. The first one, which whether or not you're familiar with the specifics of our implementation, the CMR's implementation of Stack, I'm sure everyone's familiar with Stack at least. Stack in particular is becoming a widely used, accepted, and utilized format. And we have had Stack as part of CMR for quite some time now. We have yet, or hadn't until recently, really settled on how we wanted Stack to be utilized, or how we wanted to utilize Stack to best represent our data and our tools. And so I wanted to go through kind of some amount of where and how we started that, and then where we are today. So a quick history was what I'm going to call the fumble, our course correction, and then where we're going in the future with Stack in particular. So from a history perspective, Stack was a contract or accomplishment, if you will. So we had CMR, and we had some work to implement the Stack format. CMR is a very complicated API. It's very, very feature rich. It has many capabilities. And so to add something like Stack on top of it, or quite frankly, add anything on top of it, is quite a hefty task. And so in doing the Stack work on top of CMR, without the historical knowledge or the kind of deep-rooted desires and capabilities of CMR, it can be challenging. And I think we definitely saw some of that. We also are aware of the fact that many API layers, I consider Stack as kind of just a communication kind of medium or format for APIs and data in general. And the data store is often the thing that is the limiting factor to how performant and feature rich your API can be. And in this case, we are using the the CMR API under the hood to accomplish the capabilities and features of Stack. And even to this day, but especially in the beginning, performance and features were limited due to the capabilities of the CMR API. And so we have had to and will continue to make improvements and changes to the CMR API to ensure the performance and the ability to add features to the Stack endpoint in the future. Ambiguity is really just the best way to offer the API to clients, right? So I don't want to call the Stack format ambiguous. It's more just that it's a loose specification that can be utilized a number of different ways. And once you establish those norms, people start to rely on those things. And sometimes those feature sets and capabilities are defined, and maybe there was mistakes there. And I think that when you make changes in the future, it makes it more challenging to make those changes because, again, people expect them to work the previous way. And so we really have to, and we are doing this now, getting a lot more feedback from users as to how they want to do it versus making any assumptions. And then we did reach a final, what we call an official release, and we put those feature sets and those capabilities in the hands of the users, which was great. But I'll go through a little bit of maybe some things we could have done, but also what we're doing in the future to prevent some previous mistakes. The thing that we're calling, or I'm deeming, the fumble. So we knew that there were limitations here. We experienced some performance challenges, and this is, again, due to the underlying implementation of the CMR API and how the Stack format had to communicate with Stack. Now, things like paging or different capabilities of how users that use Stack want to get their data. And that was never a use case, for instance, for the CMR, right? And so the performance implications of doing something that you didn't design your API to do can be pretty harsh. And we definitely saw that. And so in the midst of attempting to make some improvements to that, we lost a crucial development resource. And this is a project that had 1.5 dedicated people to it. And when you lose the one that was dedicated, a lot of the attention and lack of documentation that you thought you maybe didn't have to worry about becomes a huge deal. And then due to the fact that we don't have the resources anymore, and we're now in this weird state of, we knew there were performance issues. There's this piece of software that's crucial to the community, and we kind of lost track of where we were going with it. We started to fall way behind in these community use cases and where the overall science community was going with Stack. And so as tools like Stack Browser, for instance, started to expose functionality for other Stack APIs, ours was falling behind, and that was a big problem. So we took a step back and realized, okay, these are the mistakes we made. This is where we need to kind of go from here. We tried to determine where can we start to chip away at these problems and how can we start to move forward with it. So we took 3, I'll say, approaches, if you will, maybe 2, depending on how you look at it. One is we had a mass of requests and discussion across I'll call it the community, but this was in tickets internally, forums, repositories, and kind of all over. And so we went through all that previous feedback, and we pulled out some capabilities that we knew that were highly requested from our user base. And those were the searching capabilities that allow you to actually accomplish what Stack Browser and many of the use cases that we're using Stack would allow us to do. So we most recently delivered that. We also had a bunch of use cases that were, and I don't want to put the blame on any individual or team or tool, but like they were kind of silently broken use cases, right? Because there's no error necessarily. And I don't think that we have a good way of reporting broken linkages, right? So we're using Stack Browser as our test. And so if something just doesn't render in Stack Browser, but it wasn't because the tool threw an error, it was more that the format wasn't correct. And so we didn't, and still today, honestly, don't have a good way of tracking when those things break down. And so that second bullet point there is using Stack Browser as a test. This is not the definitive source of truth for all pieces of functionality, but given that it's a UI, it's relatively easy to ensure that when you click on certain pages, they're rendering correctly. And so we started to use that as one of our testing tools versus just automated tools that say, yeah, there's data coming back and it looks like this. If the browser or the specification, for instance, has moved on from a particular format, we need to make sure that we are also keeping up with that. And then in order to, having gone through this effort of trying to gather all the feedback from the forums and repositories and tickets, we have started to heavily utilize the CMR Stack GitHub repository as our source of truth when it comes to feedback and requests and ways to communicate with the overarching community. That doesn't mean we've ignored the other ones. We still try to drop in, specifically to the forums, and we have tickets and feedback forms. But we're doing our best to really engage with that community on GitHub, because typically the users and usages of Stack frequent the repository and the code. And so we have found this to be a very successful place for us in our kind of gathering and communicating with the community. And this also means when releases come out, release notes via the repository and feedback as well has been really successful for us. So what is next, right? So we had the history, we've come through and we've decided that we need to make some changes. We've made some changes. We have a unified place to receive our feedback now. And so outside of feature requests, because I think that the repository being used as a good place to start collecting feedback from a feature request perspective, we know that performance and other things related to performance and features are also kind of key here. So what is next for Stack from our perspective now that we have those things squared away? One of the biggest things that CMR faces with our Stack implementation is just volume. Not traffic necessarily, but just the amount of data. If you were to look across all the deployed instances of Stack today, the amount of information or records is typically very, very small. And so it allows those endpoints to do things very performantly without a large cost to them or a large infrastructure. Unfortunately, we are in a state within NASA where we have nearly 2 billion records today. And over the next 5 years, we're going to see some tremendous growth that's going to put us in the 5 to 8 billion record spot. And so we have started to experiment with a couple of different ways. Most recently, an effort we're calling Big Stack, which is just short for billions of granules stack. And this effort is really trying to determine whether or not the current implementation of CMR can support this. If not, let's look at a couple of different implementations, both kind of custom off-the-shelf tools and everything in between, to allow us to performantly and cost efficiently store 5 to 8 billion records so that anyone using the Stack API and any of other APIs are able to get access to their data in a timely manner. And also, again, do this at as little cost to NASA as humanly possible. Our goal here, though, and I think that we had one person ask a question early on in this effort, which I really loved, which was, who are we taking with us? And I think that if we look back at our implementation of Stack and how we kind of just tried to hit the ground running and go, we didn't really do a great job of engaging the community, which is largely the most important piece of this effort and this API. So this way, or this time, we've organized a number of different calls across, I'll use the term stakeholders here, and we're modeling this much after the Stack implementation that we already have today, where a lot of this discussion is happening as in public as humanly possible. So we have open discussions with the geospatial community. We are attending conferences and discussing large data sets with things like GeoParquet and other cloud native formats. And so we're doing our best to engage as often as possible, getting feedback and getting contributions from outside contributors to help us build this, because we don't want to build it in a vacuum. So here you can see we kind of had a tool that we implemented, noticed that there were some mistakes that we had made. We tried to, as quickly as possible, catch up with those features. I think most recently we have caught up on a couple of the bigger features. We have centralized our communications in GitHub, and we're starting to lay out what the future looks like, and doing so with the community related to this particular effort. So before I go on to anything else, just to kind of keep things on top of your mind, if anybody has any questions related to this particular effort or tool, I'm happy to take those right now. We can maybe take the next 3 or so minutes if you have questions. And I can't see the chat if there's any in there. Okay. Cool. Well, I'll move on to Earth Data Search, the second tool that I wanted to discuss today. So Earth Data Search is a widely used tool for searching and discovering NASA's more than 50,000 collection data set. It's also, obviously, with those 50,000 collections, that is what houses our 2 billion granules. And so this is a crucial tool to our users and the scientific community. As we look at the stakes of a tool like this, it's relatively easy to determine the importance of this, right? So when you've got 50,000 records or collections being collected by NASA, which are, of course, growing, and 2 billion records that contain data for the science community and also growing very fast. We know that that's a very important thing that we need to be taking feedback from, and we need to be evolving as quickly as possible. And so the tool itself helps you find the data, and that's important. But at the same time, it also offers, as you can see noted here, browse images being able to be previewed, downloading large amounts of files and pieces of data from the tool itself, customizing the data before it even gets to you. And so there's a lot more to Earth Data Search and the billions of records that it exposes than just being able to search the information. So going forward, and the feedback that we're receiving from people, a lot of it is around ease of use and capabilities once I have found my data. So a lot of what I'm going to go through today with respect to Earth Data Search is going to be around the features that we have implemented, again, based on feedback. So just like Stack, these tools have a vast feedback pool, and that comes in the form of all kinds of things. So we're seeing feedback from conferences. For instance, we go to AGU and we spend, I've been to 6 ESIPs, I think, in the summer, and I do my best to gather feedback at every single conference I go to. We do have open source. We have contributed or taken part in Hacktoberfest, where community members have been able to contribute to Earth Data Search. So there's a lot of feedback that comes into this tool, but it is one of the more widely used tools. And given that it's a UI, the feedback has to be taken and analyzed so that we're not just slapping Frankenstein features on and then making it more and more confusing. So what I'm going to do is I'll highlight these bullets now, and then I'm going to switch over to my browser, and everyone's going to cross their fingers and toes that the demo will go well for us. But I want to walk through. So I'm going to highlight these things now, and then I'll jump over to my browser after I've kind of explained a couple of these things. So the Earth Data Search tour, we had a tour ages ago, and we removed that feature However, it became apparent based on feedback and usage kind of metrics that we have that there were some confusing points that weren't overly confusing, but were definitely not clear. And so we reintroduced the tour to Earth Data Search. So now when you go to Earth Data Search, you're presented with a pop-up, and it walks you through some of the highlights of the application to inform you what certain things are capable of and what they do. We've had some great feedback on this, and I think it was a very good reintroduction. And we've already evolved this particular feature since we reintroduced it just a couple of months ago based on even more feedback. The Earth Data download application. So this is a tool that we have had a script in Earth Data Search for ages now. I've been here for nearly 10 years, and it was there when I got here. And it was just a script that was written for Bash. And it didn't work well or at all on Windows, definitely didn't work in Linux. And so it was very restrictive. And what that tool did was when you would choose the data you wanted to download, it would download a script to your computer, and that script would then run and download all the necessary data to your local machine. It was very, I'll use the term dumb, in today's terms, like it had no ability to stop. It had no idea of what continue looked like. It had no progress bar. It had none of those things. And so it wasn't super useful, but after years of talking about it, we just couldn't come up with a good implementation as a browser plugin, as another better script, until about a year ago, someone came up with the idea of writing what's called an Electron application. And if anybody uses Slack is an Electron application. And it's a new tool that allows us to write JavaScript and will output tools to multiple operating systems. And so now these tools are available on all the platforms that I just mentioned, Linux, Windows, and on your Mac OS, all written in JavaScript. And so we're able to get a vast majority of all the bullets that we had long considered necessary for this tool. And so this tool now, when you download data from Earth Data Search, it actually downloads this application. It's been downloaded nearly 25,000 times already, and provides a really nice and seamless experience related to downloading all the data you might need for your tool locally to your computer, with the ability to stop it, pause it, restart it when you get home. If you're at the office or the university, you can pause them and restart them when you get there, which is fantastic. Analysis in place is another big one. We're making, I'll call them baby steps to actual in-cloud analysis, right? So we're all familiar with many of the tools we have today that are applications running a computer. And once you download that data, you can then run some data on it. We want to offer or get as close as humanly possible to allowing as much of that analysis to happen right in Earth Data Search. So our first step is the ability to download Jupyter notebooks. And so these notebooks are tied to a particular data type or collection in CMR. And that allows Earth Data Search to link to a Jupyter notebook. And so when you download these pieces of data, you have an option to, rather than downloading the data, you can download the notebook that will allow certain analysis, like recommended analysis, that you can then cater to your needs and make slight modifications to run the analysis without having to understand how those tools work. You can now just modify some configurations and get actual science data out of it. The CloudFront caching. This is a huge one. When it comes to a UI, we want to make sure that it's as efficient as humanly possible. And when users are waiting 3, 4, 5, 6, 7 seconds, and the longer you are from the east side of the United States, this takes even longer. So more recently, we enabled CloudFront caching, which is edge caching of this tool. So now when you load Earth Data Search, it will now cache the website itself to remote nodes, which improves the experience of Earth Data Search quite drastically, making it easier and quicker to get to our data without having to sit around and wait. The Swaddler service integration. This is a huge one that started in discussions about 2 years ago, I want to say, where we had a tool that was spun up from the SWAT team that has an API and an interface involved with it. And the realization is that the Swaddler team is having to work on a mapping interface and a custom API. One of the things I really focus on personally is trying to reduce the number of UIs while letting highly specific science teams work on APIs that accomplish their specific goals. And so this one was a collaboration between the Swaddler team and Earth Data Search, where we got rid of the UI for the Swaddler tool and built in the functionality to Earth Data Search so that now you can access SWOT tools or SWOT data with the same UI through Earth Data Search, but it's utilizing their custom API, but the user doesn't have to know where it's going. And so now we have the same experience of searching, discovering data, and we've added another kind of back-end tool for processing that information, which is fantastic. Concatenation services. This is very similar, where we have a tool called Harmony, which is just a back-end tool for processing and subsetting data. And there's a bunch of different things that tool offers. We're doing our best to slowly kind of combine and chain these type of these services so that the user can just make the request. This is what I want. And our goal is to have one backend. So the users can literally say, I just want this. I don't care how you get it to me. Make it happen. And so this is our initial efforts to make that happen, where we've been able to kind of concatenate some of these services that the Harmony offers into a single request to the user. Portal browser, we've long had portals in Earth Data Search. This is kind of a way to subset or to minimize the amount of data that you're looking at in Earth Data Search. It offers some very slight kind of what you would consider white labeling or branding of Earth Data Search. So within a portal, you can have a custom logo and custom filters that just automatically filter out some data. We have exposed this capability in the form of a browser now. So it pops up. You can choose from all these different browser portals. And we've also tried to expose and educate people on how to make a portal. And so that way we can offer this experience to anybody that wants to come to Earth Data Search. And then lastly, 2 billion granules is a whole bunch of granules. The more that we can show in Earth Data Search, kind of related to this analysis in place effort, the more we can show you, the more confidence you'll have in the decision to download or to examine a particular granule. If you can't see information on it, you might not know. And so we've made improvements to this interface that will allow users to make better decisions about granules, that will reduce the amount of waste when it comes time to download the data that they actually want to run analysis on. So that was a lot of information. I'm going to just kind of touch on a couple of the demos real quick to give you guys some real quick ideas of what these things look like. First, the tour. Again, this is not anything unique. You've probably seen this a million times, but this pops up. We do have the checkbox that allows you to go away. Within Earth Data Search, we have user preferences. You can enable and disable this within there if you decide you want to see it again. You can skip it. Otherwise, it goes through and highlights all the different pieces that we think are crucial to the usage of Earth Data Search. I'm not going to go through the details of this because I think you've all seen a tour. However, again, we have gone through multiple iterations of this and really value any amount of feedback that people have on this particular effort, because it is showing to be very impactful. Next, we have some analysis in place. And so we recognize that sometimes when we put things in the tool, that it might not be as visible as people would like. And so I think this is one of those things where we know how people interact with Earth Data Search. It doesn't mean it's the best use case, but we know where they expect to find things today. So in the typical granule card, we call this in Earth Data Search, you can see the plus sign. So when I'm looking at this, that means I can add it to my project. And if I add multiple granules to my project, I will ultimately get multiple granules as my output. I can download this particular granule. If I really just want the information for just this one thing, I can take care of it here. No need to kind of go through the rest of the process. And then we've added this guy right here. This document is the analysis in cloud. So if I click on this, you can, or rather hover over this, it says download sample notebook. I think, still have that up. I do. So rather than downloading it, I'll just show you. This is that file downloaded. And again, not going to go into the details, but you can kind of see what we've provided in here. So this is a Jupyter notebook that provides a whole bunch of usage information, an overview of what it's doing, troubleshooting, and then it gets into the actual meat of it, which is installing dependencies, importing those things, authenticating with Earth Data login, and then eventually coming down and using our X-ray tools and actually processing this information. The output of this file, depending on where you're coming down here, is an actual image that shows the data displayed in this granule on a map. And we only ever had to go to Earth Data Search and download this notebook and click play. So no additional tools being necessary, no other interfaces necessary. And now we have analysis being done within a single click from Earth Data Search. Next, we have our granule cards. So again, we have browse images here, but they're kind of small, not a whole lot there. And there is a chance that there's actually more than one. And so we have this preview down here now, and you can see we can scroll through if there are different images and what they are. We can see down here, there's a little key with essentially a legend, which has NDVI and EVI. I'm not going to pretend to know what that actually means, but there are two different browse images of this data. And this really helps understand what it is that we're looking at. And if there are a whole bunch of them, you can see the names of those images there if it's helpful to the user. We can also expand this if it is too small to understand. So a super helpful tool to kind of ensure, this one is like very clear and pretty. It has a bunch of information. Oftentimes there's less information than this. And so being able to see it really helps. And then lastly, you can see here with this, the Swather tool. So with an Earth Data Search, one of the things you can do is when you're looking at your granules, you can choose how you want to get your data. Downloading it directly has been something we've offered for ages. And then next came OpenDAP customization. Harmony is the one that I was speaking about earlier. And this is the kind of concatenation efforts you can see here a little bit where like we have one here using Haas. But this used to be multiple Harmony records if there were multiple things here. And now it's rather one thing. And we've really tried to, with the help of Harmony, concatenate these efforts a lot more. And so that effort just makes it a little bit more clear here. This is essentially choosing who you're going to send this information to. And so the one that we are discussing here is this Swather integration. One of the key pieces of Swather is that it had a custom interface for choosing and subsetting the data. And so we've been able to replicate that interface for Swather. And this effort is really the beginning for us to say, if we had a custom API or 20 custom APIs, how can we start to utilize some piece of technology that we write, some piece of code that allows us to introduce these custom form elements that never used to be a part of Earth Data Search, that allow other people to focus on just the science and the data, the API aspect of things, while we manage the overarching search and discovering capabilities of their data. And so this is a really good representation of what that looks like, where we now have a fully custom UI within Earth Data Search that allows us to download the data. Sometimes this takes quite a while, so I'm not going to bother going through that information today or for now. And then the last thing I'm going to show you is that portal browser. And so we can just go to search. And we have this button here where we can browse our portals. And so now you can see a couple of different options here for essentially subsetting the data that's displayed in Earth Data Search. If we want to look at just the PODAC cloud. So we have this minor branding up here. Our information is all filtered. So our initial call and every call thereafter to CMR has automatic filters applied to it. And you'll see that all the information coming back here is specific to PODAC's cloud collections. And so this is really helpful for both users at the DACs, but also for scientists who just feel a little bit overwhelmed with the amount of information that NASA holds. We can really help eliminate some of the extra fluff, if you will, for them. At any given time, you can just click this link down here at the bottom and go back to the full user experience. So that is all the things I want to discuss about Earth Data Search today. I'll do the same thing as last time. If there are any questions related to this effort, I'll take them now over the course of the next couple of minutes before we let the next presenter get started. So are there any questions about Earth Data Search?
There's one in the chat, if you can see it.
Hi, Ryan. Great features on Earth Data. One of the computational demanding tasks is resampling, changing the resolution. Is there a possibility to resample the data prior to downloading? I can't answer your question specifically. I can say that it's something that Earth Data Search would support. So I think that there may be Harmony services that do that. And so it would just be a matter of choosing that tool. And so oftentimes what these services that we're looking at as part of the checkout process, if you will, of Earth Data Search is that capability. And so you would then get, like on this page, which is empty at the moment, but on this page, the links that show up here would ultimately be the processed files. And so if you decided you wanted them to be resampled, the links and the files that you get here would be resampled already. And so you would not have to download the full file. The services would do that for you. Hopefully that answers your question. All right, well, for other questions, I think Eric, you were going to go up next.
Maybe you don't see the hands up.
Oh,
I
yeah.
had a
I
hand up, if that's okay.
Yeah, sure. I just saw it. Yeah, go ahead.
Okay. Hi, Ryan. Thank you. That was fantastic information. My name's Ian. I work closely with the Ocean Biology DAC, and you probably can't answer this very succinctly, but basically I want to know everything you can tell me about the Jupyter download thing, because I would love for us to implement, to be on board with that as soon as it's launched. And sort of like a specific question is like, how is that integrated in CMR? Like, how do you keep track of which notebooks would be associated with anyway?
Yeah.
I would love to talk. I would love to get everything about this so that we can do it. It looks amazing.
Yeah. So I think our contact information is up there. I think the best thing to do going forward, I think that we should discuss it. I have lots of information I could give you, but I think I'm most interested in, again, taking the feedback. What is it that you would find helpful? Right now, it's not integrated into CMR. And I think that that's one of the interesting places that we need to start doing, is we oftentimes will put things on this front end to kind of gauge interest / feedback and see how it works, to then more so justify the level of effort that we want to go into in terms of integrating it for wider consumption. And that's the same thing with that Swallow integration, right? That's mostly on the front end right now. And we have ideas of how to integrate it in the back end, assuming that's a place that people would want to go. So I would say, please, let's talk about that and get that written down, because it's a tool that we're actively developing, or a capability, and I would love to hear what you have to say. All right, I don't see any other questions. So thank you so much. I will stop sharing. And I think, Eric, we're going to go next?
Yeah.
All right.
All right. I can't tell on my screen, but I'm assuming, looks like I'm sharing something.
Yep, we got you.
Okay, cool. So I am Eric Ryder. I'll be talking about the client subscribing their AWS SQS with the CMR subscription service that was implemented in the last few months. I do want to tie this into what Ryan was saying before. We got this feedback from our users. One of the many different ways is we have a Slack community, and a lot of the NASA DACs are on the same Slack service that we are. And so they took a couple days where they really kind of went through and set up a kind of requirements, or a wish list of what they wanted. So we took that feedback and we were able to develop it. So what we did is, I'm going to basically talk about the problem that they would like to solve, the solution, the benefits. I'll give you a quick demo and then just show some links to some resources. So the NASA DACs and other CMR clients would like a programmable way to subscribe with the CMR to get near real-time notifications after observational data files metadata, called granules, have been ingested in the CMR. Right now, a periodic search subscription solution exists that provides search results to the client in an email. There are a lot of overhead to programmatically trigger processes off these emails. Clients don't want to parse the emails, and while it's periodic, the notification may be not as timely as some desire. Ideally, the DACs would like to have the notifications delivered to an AWS SQS queue so they can pick up the notifications and use them to do more processing. The notifications need to contain a few key pieces of information, granule identifiers and the granule's location within the CMR. A Firehose solution where the notifications for all ingests are delivered is not desirable or useful. And some of the DACs pull the CMR for new data on a periodic basis, and this is no longer necessary. So the solution to allow CMR clients to specify an AWS SQSQ ARN endpoint when creating a subscription so that the CMR can send update notifications to the queue. use the current CMAR subscription API to allow users to create, update, and delete subscriptions. So we didn't change the API, but we did add some sub elements to the schema. Number one is the method, which designates between search subscriptions and ingest subscriptions. The valid values, of course, are search and ingest. And if you want to use the AWS queue, you need to use ingest as the value. The mode describes whether the notification is for new, updated, or deleted granules. And the endpoint describes where the notifications get sent. At this time, only AWS SQS ARNs are allowed, but in the next 3 months, we're going to be adding URL endpoints in general. The next two bullets are just some documentation, one for the schema definition and the other one for the CMAR subscription API. The benefits reduces load on the search infrastructure by reducing the reoccurring searches, reduces the need for DAX to create polling software, near real-time notification, no need to set up and parse email messages, and it uses infrastructure that DAX already currently use, making it easy for them to integrate the notifications into their existing processes. So now I'm going to go through a demo. But first, I want to show a wiki page that we have set up that's publicly available. And it takes a client through the process of setting up the SQS queues to subscribe to the CMR. So first order of business is to set up an AWS SQS queue, and you will need to allow the AWS SNS service to send messages to your queue. And then we need to either have a collection where the granules are being ingested that you know of, that you want, either already available to you, or you'll need to ingest it. And then you need to make sure that you have visibility to it. Once you have all that, you'll need to create a subscription record. And I'll go through that briefly here. And then you'll need to ingest that record into the CMR, confirm the subscription, and then after that, your queue will be ready to receive messages from the CMR. So the first thing that I did, I'll go here first, is I created a free tier AWS account. And in this account, I created a queue. So it's a default queue that I've created within SNS, or excuse me, within AWS. And this is the console that you go to for your queue. And you can do everything that I'm going to do that I've scripted manually if you wish. The one thing I want to point out that you must do is inside of the access policy for your queue, you need to allow the AWS SNS service to send messages to your queue. And that's it. So once you've done that, then I'm going to go ahead and just create an AWS session. And then I'm going to get my SQS queue URL. And now what I need is, in order to create a subscription in the record, I need my SQS ARN. You can use the URL and get parts of it to create the ARN, which has a pattern, or you could just go to your console and get the ARN value directly. Well, you'll need it inside of your subscription record. So we'll go ahead, and I've already created a subscription record. I gave it a name. It's for the granules. My subscriber ID is my Earth Data login. My collection concept ID is the CMR concept ID for that collection where the granules are being ingested. My endpoint is my queue ARN value. The mode is what do I want from these granules? Do I want just new granules, updated granules, deleted granules, or a combination of those? I'm asking for all of it. The method is ingest because I want to receive the notifications in my queue. And the metadata specification designates the schema that my record is going to be validated against. So once I have a record, I'm going to send the record and subscribe with the CMR. So I'm going to go ahead and subscribe it. Now I've got a subscription. Now, once I've subscribed to the CMR, AWS is going to send a message from the CMR to your queue in order to confirm the subscription. So we're going to go ahead and read our queue, and I've received a message. And I want you to notice the type. The type says that this is a subscription confirmation. It has a subscribe URL, and the message tells you what you need to do. You have chosen to subscribe to the topic, so to confirm the subscription, you need to visit the URL. So that's what we're going to do. So I'm going to go ahead and visit the URL. And then now, once I've done the subscription, AWS finishes the process. And now I don't need this message anymore, so I'm going to go ahead and delete it. Now, sometime later, the content provider is going to ingest some granules. So we're going to go ahead and do that. And now, once the provider has ingested granules and it meets the criteria of your subscription, the notifications will arrive in your queue. So I'm going to read our queue, and I can see that I got a message. I'm going to notice the type is notification. The subject, which I have, is update notification, so I know that I got an update. The message has the granule identifiers in it, plus the location of where I can get the metadata. So the ask from the DAX was get the concept, the granule concept ID, the granule UR, the producer granule ID, and then again, how to get the location, how to get the granule quickly. And then there's a message attributes, and these is used to filter out the message that will get to your queue. So it's the collection concept ID, and again, the mode, which this time is I got an update. So that sent then this notification to your queue. Once I have the message, I can process it, do whatever else I need to. And when I'm done with it, I need to delete it off of my queue. So I'm going to go ahead and delete it. And FYI, your software that you run, if you're going to do this, you need to be able to handle if the same message comes up again. It's an artifact of the AWS at least once delivery. It's rare, but it can happen, so you need to be able to handle that. Now, after some months or years of you getting the information through your queue and you're all done with it, you can go ahead and delete the subscription. And that basically concludes my demo. There's documentation that's available. AWS has great documentation on doing this manually. They have great documentation and code examples to do this in many different languages. We have links to our subscription schema that you can use to create your records, the CMR API documentation to send the record to the CMR so that you can subscribe, and the wiki page that I showed you at the beginning of the presentation. That pretty much concludes my demo. Are there any questions? If not, then I'll hand it over to Chris Goki.
Yep. All right, let me share my screen. Share. Yep. So you should see the screen. I think that's just over the top. 1 second. Okay. Assuming everybody sees this. Good afternoon. My name is Chris Goki. I'm a senior software developer on the EED program. Today is about our Earth Science Vocabulary System and some of the upcoming changes that are in the works. So I'm going to try to mix this presentation up just a little bit. I'll talk about the existing version of KMS that is currently live in production, then jump into a demo showing current features and workflows. And then talk about where we are moving with KMS, talk a little bit about an early prototype we did using an RDF database, a little bit about SCOTS, how we are going to continue to build on it, and where that might lead in the world of ontologies.
Hi, Christopher. So sorry to interrupt you.
Yep.
We're seeing the presenter view right now.
Oh, you're seeing the wrong one. How do I? How about now?
Yeah, we're still on the presenter view.
Okay.
Yeah, if you share your whole window, your whole screen, just choose the other screen when it pops up.
Try that. 1 second here. Stop share, new share, then allow to share window. So what do I do here? Say that again, Ryan?
Do you have 2 monitors?
Yeah, 2 monitors. Yeah.
Yeah, so just when you choose the which screen to share, just choose the other one. It's going to share the one with your taskbar at the bottom.
All right, let's try that again. Slide. Okay, so is it sharing the right one now?
No.
So I share the other one. I'll try one more time. If not, I'll just move it to the regular screen. All right. Any luck now?
If I could
Yeah.
make one other suggestion,
Yeah.
you might want to turn off your camera only because your audio is very choppy and sometimes it's a bandwidth issue. So it helps to turn off your camera.
So which one
And
are you
we're
seeing?
We're seeing the entire PowerPoint, so we see your slide and then also your notes too.
Yeah, I don't want to do that. Let me see here.
Under slideshow, if you click on slideshow across the top, you click show media controls. I'm sorry, I'm trying to read close here.
Go to presenter view. That's showing the wrong screen. I don't understand why it's doing that. How about this? Allow to share a window. Maybe I can define the window. No, that won't work either. So I don't know how to get it off of presenter view then. Screen. Choose the content to share. Let me try that. Maybe that'll make a difference here. How about now?
Yeah, that's good. And then turn your video off.
That is perfect.
Okay. Yeah, as my video is, I think it's off now. All right.
No, not
Are
yet.
we good? No?
Your camera's still on. Yeah, just turn the camera off for bandwidth.
The camera for Zoom. Down at the bottom, you'll see a little video camera. Just click on that and it'll turn off your camera.
Yeah, I'm clicking it and it says it's off.
I can turn it off for you.
Yeah, sounds
Let's
good.
do that.
Sorry about this. Okay, so yeah, as I said, I'm going to try to mix the presentation up a little bit. I'm going to talk a little about the existing version of KMS that's currently live and in production, then jump into a demo, showing some of the current features and workflows. Then I want to talk a little bit about where we're moving with KMS, a little bit about the early prototype that we did using an RDF database, and a little bit about SCOS, how we're continuing to build on it, and where that might lead in the world of ontologies and machine learning. So get my context here. So KMS, what is KMS? So KMS stands for Keyword Management System, and is a set of applications that manage control vocabulary. Now, KMS is used for indexing and categorizing earth science data and services within the CMR. You can think of it as labeled data, where metadata is assigned specific tags or labels. It allows for consistent searching across different terms related to the same concept. It is also used as part of linked open data, where every keyword or concept is given a resource identifier, and other ontologies and systems link to that resource in KMS. So KMS is really composed of two applications. It consists of a RESTful web service, which is on the left here, is an example of the capabilities document, and a UI component called Keyword Manager, which is on the right. So I wanted to give a little demo of the existing features of KMS before we jump into the kind of the new things. So Keyword Manager is an internal tool that we use, GCMD Earth Data / Keyword Manager, and basically it allows our users who are developing ontologies or taxonomies to be able to like add new keywords, remove keywords, and come up with all the different hierarchies. They fit within a number of, so we have a number of different schemes. So some of the more common ones are science keywords, which is what's showing here. Also projects, platforms, instruments. So there are like these hierarchies of keywords. And if you were to say double click on one of them, say atmospheric pressure, unauthorized. I don't know why I'm getting that. This worked a second ago. Let me log in again. Could be that tokens expired. Okay, so if I go down to science keywords and then hit apply, and this is the sort of the hierarchies that you can see. And then say you were to click on atmospheric winds, for example, this is the resource ID that's associated with that keyword. And it's based on the SCOS model, so it has a broader a pref label, definition, references, and then any changes that might occur to the keyword, as well as it could have alternate labels, hidden things like synonyms, hidden labels, things that might help users in searching for data regarding atmospheric winds. So the hierarchy is here. You can like if you were to add keywords, the UI has the capability to like insert, remove, rename. It has like cut and paste where you can actually chop, like cut this keyword and everything that falls underneath of it and paste it somewhere else in the hierarchy. If you're trying to reorganize, as well as things like drag and drop, you can drag and drop these keywords in different places. So this is the tool that it's basically used to manage the keywords. The workflow works by, we have a version. All the work happens in the draft version, and then periodically we publish. So there's a published new version which pushes our keywords out as a new version that goes into production, as well as it stores past published versions as well for archive versions or purposes. So how these are used is within, let me see, within MMT. I have to go here. I guess I don't have it. Within MMT, let's go to say this is our tool that allows that gives our DAX the ability to write metadata. but also if you were to want to tag a collection record with a keyword, you go to descriptive keywords, and then the keywords that that are showing show up here, and you could see that then the users could essentially tag their metadata with the keyword. That translates over to Earth Data Search, where these keywords then are used to aid users in I gotta go here now to aid users in discovering data. So in particular here, if you go down to keywords, you can see that Earth Data Search is sort of you know, these are all the atmospheric keywords, biosphere, and then if you were to click here, then you can kind of navigate your way down based on you know, how that how the metadata is labeled. And finally, like the other tool that we have is if I go to GCMD Earth Data, we have a keyword viewer. So if you just want to see all of the different keywords and all, you know, like we have, you know, dozens of different keyword schemes here. So the most common is our science keywords, platforms, instruments. These are at the top, but there are other types of keywords here. You could do searches across all the keyword schemes. So if you're looking for fire, you can see, you know, so if you wanted to find a particular keyword, it's very quick. You can drop down and see all the keywords across all the different schemes. So you see platforms. There's an Earth observation satellite platform called Firebird. Instruments. If you were to click one of these, you get all the details, broader definitions and such. So this has been the main tool for like viewing all of our different keywords and the relationships there. So that's the demo of the existing tools. I'm going to drop back in to the slides, kind of finish up the demo here. Okay, so so the current state of KMS. So we have a technology stack looks like this. It's written in Java. It uses MySQL with Hibernate. It has a GWT front end, and the pages are served out through Jetty Server. So as you can see, the current technology stack can definitely use an upgrade, and that's what we're looking to do in the next several months. For example, Hibernate works great as an object relational manager, but in practice, we found it slow and difficult to extend the model easily. GWT is a JavaScript framework for creating rich web user interfaces, but isn't surpassed by much better technologies such as React, Node.js. So we're aiming to replace these technologies with something a bit more modern. Right now, the data model represented in Hibernate essentially is based on SCOS, which I'll talk about in a few minutes. So we can export our data pretty easily to the SCOS RDF. And so that takes us to the next slide here, where that's what we did. We developed an early prototype using Node.js, and that interacts with a RDF compliant database. We use for the prototype, we used RDF4j, and we imported all of our RDF data. The application is built using serverless, and the plan is to build a React front end similar to Keyword Manager that I showed earlier, with integration into MMT tool that I also showed. So what did we do? We exported our KMS database as RDF, and then we imported all that data into RDF4j. That resulted in about 15,000 concepts, or about 160,000 triples. Then we prototyped some key APIs so we could benchmark performance. The APIs were like retrieve a single SCOS concept, retrieve a batch of SCOS concepts, finding concepts by pattern, and then a lot of our users want to export all of the concepts as CSV. So those are the key ones that we chose, and we got significantly faster results. As you can see, like in the 99th percentile column, the results range from 2 times faster to much faster. Much of the slowness was attributed to us storing our data in MySQL with that ORM wrapper rather than a native RDF database. So it definitely makes sense for us to move to something closer to the actual representation of the data itself, which is in RDF. There are other reasons too. Real quick, we want to continue to build on SCOS. SCOS stands for Simple Knowledge Organization System. That is a W3C standard for representing thesaurus, taxonomies, ontologies, classification schemes, the kind of the type of data that pretty much is built for. So the model that we chose is correct, and we want to continue working with that model. And for the terms that are, for the most part, they're hierarchical and associative. So you can see like just an example of SCOS where, you know, you've got a concept like Terra, and you can see that it has a broader concept space-based platforms and even broader term Earth observation satellites. And MODIS also has its broader term, but there's also a associated relationship where Terra where MODIS is related to Terra. MODIS is an instrument on board the Terra platform. So that's a lot easier to visualize in a graph. You can see the relationship clearly, the broaders and the narrowers, and then the associated relationship with MODIS. But our goal isn't like SCOS provides sort of the basic framework for dealing with taxonomies, but you know, once we start moving into RDF, then we can add other custom properties. You know, such as like for example with Terra, we can have a namespace where we can basically say that Terra has these instruments, and we can list the 4 instruments, or MODIS is on this platform, and we can start beginning to add these custom properties for more specific types of relationships. And then we can go even further by expanding the vocabulary. Right now we have like measurement names, we have science keywords, so there's no reason that we can't take an instrument and, you know, like this instrument is related to cloud cover and it measures these things. There is some effort here of doing these kind of relationships along with, you know, things like platforms and missions and projects and how all these things relate. And that, so basically what we're doing, we think sets us up for a fairly extensive knowledge graph, and moving to an RDF database sets us up for using ontologies and inferences. And I think that's the direction that we would like to go. SCOS can then be mapped to OWL using some pretty basic rules. And inferences, they play a crucial role in drawing conclusions, making predictions, and uncovering new insights for existing data. Inference involves using logical relationships like transitivity, equivalence, subclassing to derive new facts that are not explicitly stated, like in that in the actual taxonomies or the data itself. For example, in the 3rd bullet here, that has influence using transitive relationship like El Nino, that can have an influence on global weather patterns. Global weather patterns can have an influence on temperature and precipitation. So we can make an inference that El Nino has an influence on temperature and precipitation. So if the user wants to know what sort of influences El Nino has, we can point them to temperature and precipitation through the transitive relationship that an inference engine can pick up. And obviously, machine learning AI is a huge buzzword these days, and for good reasons. So the question is there an intersection between semantic web and machine learning AI? And I think yes, mainly because SCOS and RDF provide a structured way for understanding domain knowledge. I think that enables machine learning models to better understand and process the relationship between concepts, facilitating more informal learning. And then there's reasoning over data. We can infer new facts or relationships based on existing data in ontological structures. This can be useful in tasks like natural language processing or recommendation systems, where context is key for making predictions or suggestions. Then there's automated data labeling. That's where supervised learning and machine learning model is trained on labeled data. The quality of these labels kind of directly impact the model's ability to learn and generalize. So in the screenshot below here, I'm seeing some interesting work done by some within semantic web machine learning, where there's an RDF database. In this particular example, they represent movies, so it stores and relates information such as the movie name, directed by, years, studio, genre, and they applied a machine learning classification model that helps predict the genre based on the director, year, and studio. So I think we'll see more of these kinds of things. And then the next to the last slide is, in fact, several years back, we had a technology infusion effort where another group called the Impact Team developed a machine learning model that leverages the semantic embedding ability for word to vector models to process metadata descriptions and suggest relevant keywords using KMS. So I'm going to show a quick example of that, and then I'll be done. So let me go back to here, and I have a really interesting work done by the Impact Team, where basically, so I'm going to create a new draft here. And then I'm going to go down to the abstract, and I'm going to paste in an abstract here. So this is a data set provides high resolution surface reflectance thermal imagery, basically over California, collected before and after some mega forest fires. So there's a lot of information in this abstract, and the purpose of this GCMD keyword recommender tool is to suggest keywords based on whatever's in the abstract. So if you go to descriptive keywords, and you can see here, it does a pretty good job of helping the metadata author select, potentially relevant keywords, fire occurrence, land use, land cover, classification, wildfires, and then they can just choose, whichever ones that they want, and then they show up as part of the metadata. So back to the slides. Yeah, and so we are looking for feedback. If you are an existing user of KMS, we really so we're going to be kind of making some significant changes toward the KMS application. So if you're an existing user, we would love to know what you like about it, dislike, ideas, requests, because and particularly we want to be able to follow as many standards and best practices that are out there. So any suggestions there would be great as well. So that's all I had. Sorry for the technical difficulties at the beginning.
Awesome. Appreciate it, Chris. Any other questions? Okay. Well, thanks to my colleagues for helping me get this information out there, and thanks for everybody that joined us today. Again, the goal here is to show everyone that we are listening. I spend a lot of time gathering this information and planning for the future of our tools. So please, if you have any feedback or requests or questions, concerns, please find us and provide whatever feedback you may have. But with that, if there's more questions, I suppose we're a couple minutes early, but given it's 5:15, I'm sure there's not too many people will be upset by that. And we can wrap up early.